Hi, welcome to the video on transportation problem. My name is Hera Shaheen and today we are going to discuss the transportation problem using Modi method. Okay, so in this type of questions you are given some table in which initial basic feasible solution is provided found by some method, suppose using northwest corner rule, and you have to find the optimal transportation cost by Modi method. Okay, so what you have to do, you have to find the optimal transportation cost by Modi method. Okay, so let me write it here. You have to find the optimal transportation cost. So first of all, you understand that what is given is the initial basic feasible solution. It is found by northwest corner rule, and you have to find the optimal transportation cost by Modi method. So you should understand what is Modi method. Okay, Modi method is a modified method of finding optimal transportation cost. In Modi method, we modify our existing initial basic feasible solution. We modify our initial basic feasible solution via series of optimality test. What we do optimality test to find the optimal solution, and we will not do only one test. We will do series of optimality tests till we didn't get the optimal solution. Okay, so first step is first applying Modi. First you find the initial basic feasible solution. Initial basic feasible solution, how you find it? You find the allocated values and the cost of that box, multiply and add all those values, and 9 into 5 plus 3 into 1 plus 7 into 4 plus 7 into 0 plus 4 into 7. What we are doing, we are multiplying allocated values with the cost of that cost which is given in that cell. So 9 into 5, 3 into 1, 7 into 4, 7 into 0 and 4 into 7, and we are adding all of them. So now the result will be 45 plus 3 plus 28 plus 0 plus 28. So it will be 104. Okay. Now the next step is, or you can say the first step, step 1 is check for degeneracy. Check for degeneracy. Degeneracy, how you will check? Number of allocations. Find number of allocations. Number of allocations here is 1, 2, 3, 4, 5. How many allocations are given? So it is 5. And you have to find that this number is equal to m plus n minus 1 or not. Now what is m n minus 1? Number of allocations should be equal to m plus n minus 1, and m and n is number of rows and columns. M is row and n is column. So here in this question, your number of rows and number of column is 3 and 3. So now this 3 plus 3 minus 1 is 5, and number of allocation is also 5. So number of allocation is 5, and m plus n minus 1 and m plus n minus 1 is also equal to 5. How? 3 plus 3 minus 1 is equal to 5. Okay. So what we are getting, that number of allocation is 5, m plus n minus 1 is 5. So both are equal. That means this is non-degenerate problem. If both are equal, means it is non-degenerate problem. If it is true, it means it is a non-degenerate problem. Okay, it is non-degenerate problem. Okay, so now, and if it was not true, if the number of allocation is different from m plus n minus 1, then that is called degenerate problem. Then we have to use some other method. Okay, but if we find that the solution is non-degenerate, then we'll proceed further. Okay, so what you do, as I'm telling these things, you pause the video and note it down the points, because I cannot write everything here. Okay, so you write it down that if the number of allocation is different from m plus n minus 1, then that is called non-degenerate, that is called degenerate problem, and we have to use some other method for solving that kind of problem. Okay, there's a special technique for that, solving that kind of problem. So now the step 2 is, since it is non-degenerate, we can proceed further here. So the next step is calculating opportunity cost, which is known as optimality test, and it is done using UV method, UI plus VJ method for occupied cell. First we will use for occupied cell, then we will find opportunity cost for unoccupied cells. So let's start for the occupied cell. We will see what are the cells which are occupied, and we will number UI for rows and VJ for columns. So what you are seeing, that first row and first column, U1 plus V1 has value transportation cost 5. First look into the table, given table, that first row and first column has the transportation cost 5. Then U1 first row and second column has transportation cost 1. Okay, then second row and second column has transportation cost 4. Second row and third column has transportation cost 0, and third row and third column has transportation cost 7. Okay, so after that what you have to do, you assume any one value as 0. So let's take U1 as 0. Let U1 is equal to 0. Then we can find V1. What is V1? V1 will be 5. So V1 is equal to 5, and when we put V1, and we can find V2 also, from after, when we are assuming that U1 is 0, then V2 will be 1. Then what will be U2? U2 plus V2 is equal to 4. Then U2 will be 3. Okay, now U3 plus V3 is equal to 7, means V3, first you have to find V3. V3 we can find from here, V3 is equal to minus U2, v3 is equal to minus u2, and u3 plus v3 is equal to 7, means u3 is equal to 7 minus v3, and v3 is 3, 7 plus 3, then u3 will become 10. Okay, in this way we will find u1 v1, u2 v2, u3 v3, these values. Okay, now the next step, in the same step, what you have to find, you have to find opportunity cost for unoccupied cell, and that is done using del ij, and it is found using the formula del I comma j is equal to Cij. Cij is the cost minus ui plus vj. Okay, Cij minus ui plus vj, and Cij is the transportation cost. So del ij means I will use ij for the unoccupied cell. So what is the first unoccupied cell? First unoccupied cell is 1 3, first row and third column, del 1 comma 3. This is unoccupied cell. Okay, so what was the transportation cost there? It was 8 minus ui. Ui means u1 plus v3. u1 is 0 and v3 is minus 3. So it will become 8 plus 3. 8 plus 3 is 11. Okay, so it is 11. Now del another unoccupied cell is 2 1, second row first column. So Cij for this is 9 minus 3 ui. u2 is 3 and v1 is 5. So we'll add this ui plus vj, and 3 plus 5 is 8, 9 minus 8 is 1. Okay, now del 3 comma 1. Del 3 comma 1 is the next cell which is unoccupied. So the transportation cost is 17 there, minus u3 plus v1. u3 plus v1. u3 is 10 and v1 is 5. So this will become 2. Okay, now next unoccupied cell is 3 comma 2. So del 3 2, and del c32 is what? 6 minus u3 plus v2. What is u3 plus v2? u3 plus v2 is 10 plus 1, which is equal to 11 minus 6 minus 5. This is minus 5. So what are the values we are getting in? And we have calculated all the unoccupied cell. And in the next step, what you have to find, that whether all these value del ij are greater than 0 or not. If all the values are greater than 0, then solution is both optimal and unique. Okay, write it down. If all the values are greater than 0 in del ij, what you have to check, if all the values are greater than 0, then solution is both optimal and unique. If next step, next rule says that if all the values are greater than 0 and one value is equal to 0, then solution is optimal but not unique. Okay, so let me write these rules. So after finding del ij, we'll see the rules, and the rule says that if all the values are greater than 0, then the solution is both optimal and unique. And if all the values are greater than 0 and one value is equal to 0, then the solution is optimal but not unique. And if one of them is less than 0, then the solution is neither optimal nor unique. Third rule is, if one of them is less than 0, then the solution is neither optimal nor unique. So we have to see this rule. 11, 1, 2 and minus 5. 11, 1, 2 and minus 5. Here we had seen that one of the value is less than 0. So our present solution is neither optimal nor unique. Then what we have to do? We have to modify our solution. And then so the next step is to modify our solution. We will do this using looping and reallocation. Okay. So let's see that step. Now in this step, what we have to do? Looping and reallocation. So our given table was this. Okay. And now what we have to see the rule that we have to create loop. But how we will create loop? Using these rules. Okay. So first rule says that loop must be closed. That is, starting and ending must be same. And starting and ending point of the loop must be unoccupied cell. Okay. So like this one, this, if we take this loop, okay, starting from this, at all the three corners there are allocated values, and we are starting from here and ending here. Okay, and the rule says that loop must be closed, starting and ending point of the loop must be unoccupied cell, and loop may take any path, but at three corner point cell must be allocated, like this one. This is cell is allocated. So let's take this loop starting from here and ending here. Okay, now what we have to find, that the allocated values are what? So we are finding that here it is 7, and this is 4. So we have to choose the smallest one, and smallest one is what? 4. From 7, 7, 4, the smallest value is 4. 7, 7, 4. The smallest value is 4. So the next step is, what we have to do? We have to add 4 from the starting point or starting cell. Add means plus, and subtract from the alternate cells. Plus, minus, plus, minus. We have to do like this. What we have to add or subtract? We have to add the smallest value among these. The three corner points, allocated corner values. Okay, we are choosing from there, and there it is 7, 7 and 4. So what you have to do, choose, you have to choose the smallest among them. Smallest is 4. Now what you have to do? You have to add 4 at the beginning point, and alternately you have to subtract 4, then again you have to add 4, and then again you have to subtract 4. Okay, so our new value will be, what there will become, I am drawing this, here it is 5, 1, 8. So what will be our new value? We have to add 4, since the allocated value in this cell was 0. Why? Because there was no value allocated here, so it was 0. So what we have to do? We have to add 4 in this, so it will become 4. Okay, I am writing here, and in this, and the earlier allocated value was 4. We have to subtract 4 from there, so it will become 0. And in this, earlier allocated value was 7, so we have to add 4, so it will become 11. In this, earlier value was 7, and we have to subtract 4 from here. We are adding here for plus, minus, plus, minus. So we are subtracting from 4 from this, and this allocated value was 7. 7 minus 4 will be 3. So this is our newly allocated values, and the other cells will remain same. So earlier it was containing 9 and it was containing 3. So in this cell it is 9, it is 3, and the new values for this is 3, this is 11, this is 0, this is 4. So now we have to find again opportunity cost using the same UV method. Okay, for this newly allocated values, newly created table. Okay, so now let's see. For now it is u1 plus v1 is equal to 5, u1 plus v2 is equal to 1, u2 plus v2 is equal to 4, u2 plus v3 is equal to 0, u3 plus v2 is equal to 6. Okay, so these are the values we are getting from this table, modified table. Now assume u1 is equal to 0, u1 is equal to 0, then v1 is equal to 5, then v2 is equal to 1, then u2 is equal to 3, and v3 is equal to minus 3, and u3 is equal to 5. Okay, see, u3 is equal to 5, u1 is equal to 0, v1 we are assuming u1 is equal to 0, and through this we are calculating all other values. Okay, what is this? First row and first column, u1 v1 is 5, u1 v2 is equal to 1. This we are calculating opportunity cost for the occupied cells. Okay, and using this we have calculated u and v, our u and v. Now we will calculate opportunity cost for unoccupied cell. What is this? Del 1 comma 3. Del 1 comma 3 will be cost of that cell 8 minus u1 plus v3. u1 plus v3 is 0 minus 3, that is 11. Now del 2 comma 1, second row first column. Second row first column, the cost of that cell is 9 minus u2 v1, and u2 v1 is 3, u2 and v1 is 5, so it will become 1. Now del 3 comma 1, so cost of that cell is, transportation cost was 17 minus u3 plus v1, u3 plus v1 is 5 plus 5, that is 7. Now del 3 comma 3, third row third column, cost of transportation cost of that cell is 7 minus u3 plus v3, 5 minus 3, so it will become 2. 7 minus 5 is 2. Now check again, use the same rules we had used earlier. Here we are seeing that all the values are greater than 0. Since all the values are positive, the solution is optimal and unique. So now this table has optimal and unique solution. Now we will find its cost, and we will find its cost by multiplying the allocated values with the transportation cost. So it will become 9 into 5 plus 2, 3 into 1 plus 3 into 4 plus 11 into 0 plus 4 into 6. So it will become 45 plus 3 plus 12 plus 0 plus 24. So it is 84. Earlier what we had seen that the solution was 104, but that solution was not optimal and not unique. But now the present solution is optimal as well as unique. So this is your answer. Okay. So if you like my video, don't forget to hit the like button and subscribe my channel and share with your friends. Thanks for watching.